Find the value of a and b that makes the given piecewise function continuous and differentiable. So the first thing that we should do, we should talk about continuity. So there are three conditions that must be satisfied in order to make the given function, piecewise function, continuous. F of 3, so in this case the target value of x is 3. As you can see, there's a discontinuity at x is equal to 3 here. We're going to talk about whether it can be removed or not, but first notice that if you input 3, you will have a function blow up, right? Because you will have to divide by 0, which you cannot do, right? So there's no continuity at this point. So the target value is 3 for the x. So the first condition is that f of 3 should be defined. Okay, that's the first condition. F of 3 is defined. So while it's not defined here, it is defined here because 3 is part of the domain of this part of the piecewise function, right? The second function here. So f of 3 is defined. Now the second part is that the limit as x approaches the target value of 3 of the fx exists. And what does this imply? This implies that both sided limits approaching the target value, so in other words, as x approaches 3 from the right of fx, the limit of that is going to be the same as the left-sided limit. In other words, as x approaches 3 from the left of fx. Okay? And whenever the two-sided limits agree, then the overall limit should be the same value. Okay? And they must produce the same value, which we will call c. Okay? So this is the second condition. And as you can see, you might say, but how do we evaluate the limit? Well, notice first of all that the limit as x approaches 3 from the left, because here x is less than 3, of x squared minus 9 over x minus 3 can be evaluated. Even though you cannot put in 3, you can rewrite the numerator in this way. You can factor the x squared minus 9 like x plus 3 times x minus 3 divided by x minus 3. And what happens is the x minus 3 cancels out, the troublesome denominator is gone, so as a result you will have x is equal to 3 from the left of just x plus 3. And as you can see now, this is defined, right? The limit is found. Because then you can safely plug in the 3 into the x and you get 3 plus 3, which is 6. Right? So the limit as x approaches 3 from the left is 6. Right? And the right-sided limit will exist. If you take the limit, we don't know what the limit is going to be. It's going to involve a and b, but it's going to exist, right? Because there's no denominator of any kind. And that limit should be also equal to 6. So the limit of this function as x approaches 3 from the right should be 6. And a and b are specific that we're going to find. That will make sure that the limit, the right-sided limit, is also 6. So now we know that the limit definitely exists, and it should give us the same value of c. In this case, we just showed that the value of c is going to be 6. The third condition is that the limit as x approaches 3, the overall limit, as x approaches 3 of fx should be f of 3, right? F of the target value of the target value of x, which is 3, right? So f of 3, as we just showed, was what? It should be 6. It should be 6. Okay? So we can say c and then equal to 6. So we just verified that these continuity conditions are met. Now, why do we need these conditions? Well, we need these conditions because now you can tell from verifying these conditions that basically the function value for these two different functions here that make up the piecewise function should be the same, right? So we should get the left-sided limit should be equal to the right-sided limit, and also the overall limit, which is the left side and the right sided, is equal to 6. And that is the function value at the target value of x, which is 3. Right? So that means 6 should be both for this one and for this one as the function value at x value of 3. So that means we can basically say that since f of 3 is equal to 6, then we can say that 6. Now remember, how do we get f of 3? Well, we got f of 3 from finding the limit, right? Because we found the limit, since both sided limits should give us the same overall limit. The overall limit was 6, and that should be also the function value at x value of 3. So 6 is the overall limit, right? 6 is the overall limit, and that function value at x value of 3 should be also the function value for this function at x is equal to 3. We're going to plug in basically the target value of 3 for the x into this function, right? So we're going to get a and then 3 squared plus the b times 3, because that's the target value we're checking, minus 10. Right? So now we're going to simplify this equation in terms of a and b. So what we're going to get is this. 6 is equal to 9a plus 3b minus 10. Now what that leads to is an even simpler equation, right? So we're going to switch sides. We're going to put 9a on the left side. So we're going to get 9a plus 3b is equal to, let's see, so we're going to add 10 on both sides, and that will be the right-sided value. I'm just switching sides after that. So 10 plus 10 plus 6, 16, right? So 16 should be on the other side. So this is the equation we've got in terms of a and b. You might say, but how does that help us find a and b if we have two unknowns? Well, here's where differentiability comes into play. So it also says functions should be continuous and differentiable. Now, why is it not always the same? Why is continuity not automatically differentiability? Well, we know that whenever a function is differentiable, then it's surely continuous, but it's not the other way around, not always, right? When it's continuous, it need not be differentiable. For example, you've seen in charts where, let's say, this is continuous, but there's a corner, right? If there's a corner, while it looks continuous, and it is not differentiable. Not differentiable. Because you cannot find the immediate slope at the corner, right? It's a corner. You don't know, it's not a curvy end, right? It's a corner, which is a sharp end. There's no way that you can find an instantaneous derivative there, right? Instantaneous slope. There's no way you can do that. So it's not differentiable at the corner. So whereas it's continuous, while it's continuous, it's not automatically differentiable. However, here we're asked to find values of a and b such that the given function is continuous and differentiable. So they're telling you, make it differentiable. So now we have to think about what differentiability means. Well, differentiability implies that derivative, right, instantaneous slope function derivative at x is equal to 3 exists, right? Because we know whenever there's a corner, it's not differentiable. There's no derivative function that we can work out. But here, differentiability implies that derivative at x equals to 3 exists. What that means, furthermore, that f prime, right, because f prime of 3 means the derivative at x is equal to 3. F prime of 3 exists. Now, here's the thing. Whenever the f prime of 3 exists, and you know there can be only one derivative at a certain point, right? Only one derivative value, right? There can be different kinds of curves that meet at a certain point, at one point, but the derivative value will be the same. So in other words, if we take the derivative of both of these, we will be able to find the value of the derivative at x is equal to 3 and then set them equal, because there's only one derivative possible. Right? So we're going to take the derivative of both of these, but be careful, you don't want to take the derivative of this, because you remove this discontinuity by making it a simpler function, which was this, right? X plus 3. So you want to take the derivative. The derivative of x plus 3 with respect to x, of course, should be equal to the derivative of this large chunk here, ax squared plus bx minus 10, with respect to x, of course. Right? So now that you know that, you can take the derivative. So what is the derivative of x plus 3? Derivative of x plus 3 is just 1, right? Because this is a constant. Derivative of the x is just 1. So 1 should be equal to the derivative of this. Now what is the derivative of this? The a is a constant, so it's going to be there. X squared derivative is 2x, right? So we're going to write 2ax for the first term. 2ax. 2ax. Now derivative of the constant is still b, and the derivative of the x is 1, right? So it's going to be plus b. b times 1 is just b. And the derivative of the constant is 0, right? So this is negligible. So 2ax plus b. Now we're going to evaluate. Remember that we just said that the f prime of 3 is the only value. There's a unique value. There's no more than one value for the f prime of 3. There's only one derivative value possible. So 1 should be equal to the right side evaluated at x is equal to 3, right? Because f prime of 3 on the left side is just 1. Right? Because we found the derivative function on the left function here, x plus 3, that was just 1. Right? So it looks like you can tell that the slope is always 1, right? Because this is a linear function, x plus 3. And the slope is always 1 times the x, right? So the slope is 1 there, the coefficient. So it makes sense we got 1. No matter which x value, the derivative will always be 1 for this function, because it's linear. However, this is quadratic, so it will have different instantaneous slopes, right? Because it's not a line, it's a curve, right? So as a result, we should evaluate at x is equal to 3 here, because obviously this curve is variable because there's a x there shown, right? So if we evaluate the x is equal to 3 here, so as a result, this is what we should have. 1 on the left side as it was, and then 3 here makes it 3 times 2, which is going to be 6. So 6a plus b, right? Because b stays, we only evaluate the x. So look what happens. As a result, we have two equations now. We have two equations. One is equal to 6a plus b, and the other one is 9a plus 3b is equal to 16. Okay? So what does that mean? We can write them along together. So what I'm going to do, I'm going to write them together. I'm going to write 9a plus 3b is equal to 16. And here I'm going to write 6a plus b. And notice I'm writing them the constants vertically because it will be easier that way to work them out to arrive at one equation. 6a plus b is equal to 1, right? So 1. So what you want to do, you want to eliminate the b. It will be easier to eliminate the b than it is to eliminate the a, because there's a 6 and a 9, whereas here there's only 1. Right? Coefficient 1 versus 3 is easier. So if you multiply the second equation by 3, and then you subtract that result from the first equation, the b's will be gone. Right? So I'm going to multiply the second equation by 3. So as a result, this is what I'm going to have. and I'm going to subtract it, right? I'm going to subtract it as well from the first equation. So as a result, I will have this. 9a minus 18a is going to be negative 9a. Excuse me, negative 9a. And then 3b minus 3 times b eliminated, right? That's what we wanted. So negligible equal 16 minus 3 times 1, right? Because remember, the 3 multiplies the right side as well. 16 minus 3 is 13. So as a result, you divide both sides by by negative 9. The 9's cancel out, the negative 9's cancel out, and as a result, you get the a value, which is negative 13 over 9. Now to find the b value, that will be easy, right? I would just use this equation to find the b, whereas this one is harder. This one is harder, so I'm going to use this one. 6a plus b is equal to 1. We know the a. So let's find the b. So 6a, so 6 times negative 13 over 9, I'm making that substitution for a, plus b is equal to 1. Is equal to 1. So now what is that going to be? So of course we're going to subtract. So what is that going to be? That's going to be 78, negative 78 over 9. So you're going to subtract negative 78 on both sides. And that will give you the b value. So the b value is what? The b value is 99. No, actually, I should have added. I don't know why I subtracted, because we have a negative, right? So we should add. So so negative plus a positive eliminates that. So b is 99 plus 78 over 9, which is going to be 87 divided by 9. Okay, so you've successfully found the a and b values right here that make the given piecewise function continuous and differentiable. So I hope this tutorial was useful and fun. Thank you so much for watching. See you in the next video.